Video presented to you by Unique to Billions e-learning. Please subscribe it and press the bell icon. In this video, we are going to solve 3 questions from Class 9 Mathematics, Chapter 15, Exercise 15.1. Question number 2 in the exercise: 1,500 families with 2 children were selected randomly and the following data were recorded. Number of girls in a family 2, 1 and 0. Corresponding number of families is 475, 814 and 211. Compute the probability of a family chosen at random having 1, 2 girls, 2, 1 girl and 3 no girl. Also check whether the sum of these probabilities is 1. To calculate the probability, we need to know the total number of families. In this question, it is already given 1,500 families. If it is not given, you can calculate by just adding 475 plus 814 plus 211. So, in this question, total number of families is equal to 1,500. The first question is the probability of a family chosen at random having 2 girls. So, I can write probability of families having 2 girls is equal to number of families having 2 girls divided by total number of families. From this data I can easily found number of families having 2 girls is 475 and total number of families is 1,500. So, the probability of families having 2 girls is 475 divided by 1,500. Similarly, I can calculate the second question, that is the probability of families having 1 girl, that is equal to number of families having 1 girl divided by total number of families. From the data given here, I can easily found number of families having 1 girl is 814 and total number is 1,500. So, the answer is 814 divided by 1,500. The third question is probability of families having no girl. Number of families having 0 girls divided by total number of families. From the data, I can easily understand number of families having 0 girls is 211 and the total number of families is 1,500. So, the answer is 211 divided by 1,500. Now, the last part of the question is check whether the sum of these probabilities is 1. That is, we need to add all these probabilities. Let me take this as probability of E1, this is probability of E2 and this probability of E3. So, probability of E1 plus probability of E2 plus probability of E3 is equal to 475 divided by 1500 plus 814 divided by 1500 plus 211 divided by 1500. That is equal to 1500 divided by 1500 is equal to 1. Why I got 1 here? Because these three events cover all the events in this trial. Now, let us do question number 5 in the exercise. An organization selected 2,400 families at random and surveyed them to determine a relationship between income level and the number of vehicles in a family. The information gathered is listed in the table below. Data is given here and you can read the questions that we need to answer. We know the probability of an event occurred is equal to number of trials in which that event happened divided by total number of trials. So, we are going to do the questions. First question, earning rupees 10,000 to 13,000 per month and owning exactly 2 vehicles. So, the event I take here E1 is earning rupees 10,000 to 13,000 per month and owning exactly 2 vehicles. So, the probability of E1 is equal to the number of trials in which that event happened. That is, how many families with income 10,000 to 13,000 are having 2 vehicles. The data I can easily found is this one, that is 29. So, the answer is 29 divided by total number of families. It is already given that total number of families is 2,400. So, PE1 is equal to 29 divided by 2,400. Question number 2. Earning rupees 16,000 or more per month and owning exactly 1 vehicle. So, I am taking this event E2 as earning rupees 16,000 or more per month and owning exactly 1 vehicle. So, the data I can easily found 16,000 or more and 1 vehicle, it is 579. So, I can write the probability of this event PE2 is equal to 579 divided by 2,400. Now, I am going to the third question, that is earning less than rupees 7,000 per month and does not own any vehicle. The event I can write here as E3 is earning rupees 7,000 per month and does not own any vehicle. Let us look into the data for finding the value. Less than 7,000 income per month and does not own any vehicle. The number of families is 10. Therefore, the probability of this event can be written as probability of E3 is equal to 10 divided by 2400. Now I am moving to the fourth question. The fourth question is earning rupees 13,000 to 16,000 per month and owning more than 2 vehicles. So the event I can write here it is as E4 earning rupees 13,000 to 16,000 per month and owning more than 2 vehicles. Look into the data for finding how many number of families having more than 2 vehicles and income 13,000 to 16,000. It is 25. So the answer I can write the probability of this event PE4 is equal to 25 divided by 2400. The last part of this question is I have to calculate the probability of owning not more than 1 vehicle. So I can write the event as E5 is owning not more than 1 vehicle. Let us look into the data to find the number of families not owning more than 1 vehicle. Not owning more than 1 vehicle means having vehicles 0 and 1. So, the number of families having vehicles 0 and 1 is this much. I need to add all these data to find the total number of families owning not more than 1 vehicle. So, the number of families having not more than 1 vehicle is 10 plus 160 plus 0 plus 305 plus 1 plus 535 plus 2 plus 469 plus 1 plus 579. That is equal to 2062. So, we can find the probability of event E5 is equal to 2062 divided by 2400. Let us do the last question in this video, question number 8 of the exercise. The distance in kilometer of 40 engineers from their residence to their place of work were found as follows. Data is given and 3 questions are also given. We need to calculate the empirical probability that an engineer leaves. We are going to do this question. Question number 1. Less than 7 kilometers from her place of work. So event E1 I can write it as engineer lives less than 7 kilometers from place of work. So how many engineers are living in less than 7 kilometers? To find the value, let us count from the data. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So, number of engineers lives less than 7 km from place of work is 9. So, probability of this event PE1 is equal to 9 by total number of engineers, that is 40 given in the question. So, 9 divided by 40. Let us do the second question. Question number 2. In this case, event is engineers lives more than or equal to 7 km from her place of work. We can easily get the number of engineers lives more than or equal to 7 km from place of work by just counting, as we done in case 1 here. The number I will get is 31. Therefore, the probability of this event PE2 is equal to 31 divided by 40. Another method to find this 31 is by just subtracting 40 minus 9, where 40 is the total number of engineers and 9 is the number of engineers lives in less than 7 km from place of work. Why? Because E2 is engineers lives more than or equal to 7 km from her place of work. So, if I subtract engineers lives less than 7 km from place of work from the total number of engineers, I will get engineers lives more than or equal to 7 km from place of work. That is 40 minus 9 is equal to 31. Now, we are going to do the third part of this question. That is, within half kilometer from her place of work. So, event here E3 is engineer lives within half kilometer from place of work. How many engineers are living within half kilometer from place of work? From the data we can easily see that the number of engineers living within half kilometer from place of work is 0. Therefore, probability of this event PE3 is equal to 0 divided by 40, that is equal to 0. I think you understood how to calculate probabilities for different events if data is given. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also, please like and share this video.